In this video, we're going to be using the elimination method to solve some simple systems of linear equations. So in our first example, we have 3x minus y equals 6 and 3x plus y equals 0. Now when we're doing elimination, the purpose is to either get rid of one of your variables, so either the x or the y. In this case, well, in any case, really, you're looking for matching opposites. And in this case, we have matching opposites. So we have matching y's, and one's positive and one's negative. So we have matching opposites. So we're actually ready just to go ahead and just add these, which is going to give us a 3x. The y's will cancel out like we wanted them to do because we're trying to eliminate one set. From here, we'll just divide both sides by 3. That's going to give us x equals 2. Now we just need to plug the 2 in to either of our equations, either the top one or the bottom one, whichever one we think is going to be the easiest. I think I kind of like the bottom equation. So I'm going to take the bottom equation, which is 3x plus y equals 0, and I'm going to take out the x and replace it with the 2 that we just solved for. So I have 6 plus y equals 2, and I'm going to finish solving for y. So y equals negative 4, and that's going to give me a solution of 2 comma negative 4. Now, when you're doing this, when you're done, you really should check your solution to make sure that it worked out by plugging it into both equations and making sure that it worked for both equations. I've already done this, and to kind of save us a little bit of time, I've checked it out and it works. So we can say that yes, this is in fact a solution. Let's take a look at letter B. Here we have 2x plus y equals 6 and 2x minus y equals 2. So we want to either eliminate the x's or the y's. And if we look, we have matching. So our x's match with 2x each, and our y's also match. But are any of them matching opposites to make it a little bit easier? And the answer is our y's are, because one is positive and one is negative, which means we don't have to do any multiplication to get an opposite. So we can just go straight ahead and add these. And that's going to give us a 4x, the y's will go away, equals 8. And we'll finish solving, which gives us x equals 2. X won't always equal 2, it just has this time and the last time. Then we're going to look at our equations, either the top one or the bottom one, and decide which one we think we'd like to plug our 2 into to get the answer. I think this time I'm going to plug it into the top equation. So 2x plus y equals 6. So I'm going to remove my x, and I'm going to go ahead and plug in the 2 that I got as its answer. So now I have 4 plus y equals 6. I'll subtract 4 from both sides to get the y by itself, and I have y equals 2. So I have a solution of 2 comma 2. Again, you should always check your solutions. I already have, and this is, yes, a solution. I'd like you to try letter C on your own. So go ahead and push pause and work out the problem. And then when you're done, push play, and let's see if you were right. So here we have matching x's, and we have matching opposite y's. So because our y's are matching opposites, those are the ones that we will use to try and eliminate. It's a little bit easier. So we'll go ahead and we'll get to add those right away, giving us 2x. The y's will immediately cancel out, and then a negative 2. We divide both sides by 2 to solve to get x equals negative 1. And this time I think I'm going to plug the equation into my bottom equation. Now it doesn't matter which equation you plug it into. If you plug it in, you're going to get the right answer. So we'll go ahead and we'll plug it in. And that's going to give us a negative 1 plus 2y equals 5. We'll add 1 to both sides, giving us 2y equals 6. Then we'll divide both sides by 2, getting y equals 3. And that will be our solution, negative 1 comma 3. And again, we want to plug these back into our 2 equations and make sure that they work. I've already done that. Hopefully you did too. And we have negative 1 comma 3 is in fact a solution to this linear system.